Hey there guys, welcome to the video. My name is Pushpinder Gill. In this video, we're going to be talking about transpose of a matrix, right? So we're going to be talking about the transpose of a matrix. So what do you understand by transpose? Now let's suppose if I have a matrix, let's suppose matrix A looks something like this. It looks like something like this. Let's say 1, 2, 3, 4, 5 and 6. Now how will the transpose of this matrix look like? First of all, the transpose of a matrix is denoted as A dash. So this dash denotes that it's the transpose of that matrix. Now in the transpose of the matrix, this column here would actually become the row here. So 1, 3, 5, which is a column, is going to become 1, 3, 5 as a row. And this 2, 4, 6 column is going to become 2, 4, 6 as a row. Right, so the columns over here, so the column 1 actually becomes the row 1 here, and the column 2 actually becomes the row 2 here. Now let's understand what actually happens in a transpose of a matrix generally. Let's try and journalize this. So let's suppose I have a matrix A, and let's say this is the first row, first column, first row, second column, first row and the third column, and it goes on like that. Let's just say it's like this only, and this is the second row, first column, second row, second column, and the second row and the third column. So the order of this matrix is 2 rows and 3 columns. Now how is the transpose gonna look like? Now we know that this column here is gonna become a row, so you're gonna have A11 and A21. Then this column is gonna become the row, that is A12 and A13, and A12 and A22, and this column is going to become the row, which is A13 and A23. Now what actually happened here? Now you can clearly observe that the order over here, it's 3 into 2. There are 3 rows and there are 2 columns. So if I say there is a particular matrix A which is defined as each element is defined as ai of j, and the order of that matrix is m into n, then the order of the transpose of that particular matrix, it's going to be equal to n into m. And what happens to each element here? See, what do we have here? This is supposed to be A21, but this is A12. This is supposed to be A31, but this is A13. This is supposed to be A12, but this is A21, right? This is supposed to be A22, so this is A22 only. This is supposed to be A23, but it's A3. This is supposed to be A32, but this is A23. That means each element ij in the real matrix is going to correspond to the element aji in the transpose matrix. So if I say, let's suppose I have this over here, this element, or let's say this element, it belongs to the second row and it belongs to the third column, right? So this belongs to the second row and it belongs to the third column. In the transpose, it's going to belong to the third row and it's going to belong to the second column. That is how this is going to be, right? So you can clearly see the third row and the second column is A23 and this A23. So this is the property of the transpose of a particular matrix, right? Not the property, this is how we define the transpose of a matrix. Now let's go ahead and understand few of the properties of the transpose of a matrix, which is very, very important. Now the first property of a transpose of a matrix is that if I have a particular matrix A, if I do the transpose of the transpose, I'm gonna get the matrix itself. Let's suppose I have this matrix that is 1, 2, 3, 4, 5, 6. So that is A, right? And what is going to be the transpose of A? That is going to be equal to 1, 3, 5 and 2, 4, 6. And what is going to be the transpose of the transpose? Again, this row will actually become the column, so it's going to be 1, 2, 3, 4, 5, 6. You can clearly see that these both are equal. So the first property is that the transpose of the transpose is going to be the matrix itself. The next property that I would like to discuss for the transpose of matrix is that if you multiply a scalar number with the matrix and then find the transpose, that is equal to the scalar number into the transpose. So let's suppose I have a matrix A, which is again 1, 2, 3, 4, 5, 6. And if I kind of find the transpose of it, that is going to be equal to 135 and 246. And if I, let's suppose, multiply a scalar number with the transpose, that is going to be 1 times k, 2 times k, 3 times k, 5 times k, 2 times k, 4 times k, and 6 times k. And if I kind of multiply the scalar number here, so it's k, 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 and k, and now I find the transpose of this matrix. This is gonna be k, 3k, 5k, and 2k, 4k, 6k. So you can clearly see that this and this entity are nothing but they're equal because the matrices are equal. So that is again a very, very important property for the transpose of the matrix. Another property which is very, very important, which you'll be using a lot in your manipulations, is that if the sum of two matrices is found and we transpose that, that is actually equal to the sum of two individual transposed matrices. So A plus B whole matrix is equal to A plus B whole transpose is equal to A transpose plus B transpose. So if I say A is equal to 1, 2, 3, 4, 5, and 6, I kind of use the same thing, and B is equal to, let's say, 1, 1, 1, 1, 1, 1. Now if I go ahead and find A plus B, that is going to be simply, if I add, 1 will get added to 1, so it's going to be 2, 3, 4, 5, 6, and 7. And if I kind of find the A plus B transpose, which is going to be equal to 2, 4, 6, and 3, 5, 7. And if I now find A transpose and B transpose and I add it, right? So A transpose is going to be simply 1, 3, 5, and 2, 4, 6. And B transpose is going to be 1, 1, 1, 1, 1, 1. So at the end of the day, I'm going to get the same matrix itself, which means that, A plus B whole transpose is equal to A transpose plus the B transpose. And the last property that I would like to talk about the transpose of a matrix, it's that A into B whole transpose is actually equal to B transpose into A transpose. I suppose you watched the previous video on matrices in which we knew that sometimes A into B is not equal to B into A. So you cannot say this is A into B whole transpose is equal to A transpose into B transpose. It is supposed to be B transpose into A transpose. And another thing that is very, very important, that that the products should be defined. When will the products be defined? I suppose you watched the previous video that if I multiply A into B, this should be of an order of m into n, and this should be of an order of n into p, right? So that the number of columns here should be equal to the number of rows here. So let's just go ahead and verify that. Let's suppose I have A to be equal to -2, 4, and 5, and I have B to be equal to 1, 3, and -6. Now if I multiply, let's suppose if I try to find A times B, what am I gonna get? What I'm gonna get, I'm gonna multiply this row here, I'm gonna multiply this row here with this column here, so this is gonna be -2. Then I'm gonna multiply this row into this column here, which is gonna be -6. This row, this here with this here, which is gonna be +12. Similarly, this into this is gonna be 4, then it's 12, and then it's -24, then it's 5, 15, and -30. So that is A into B, right? And if I kind of transpose that, A into B whole transpose is going to be equal to -2, -6, 12. This row here becomes this column, or you can say this column becomes this row. So this is 4 minus 12 and minus 24, 5, 15, and -30. So that is the A into B transpose. Now if I want to find the value of B transpose and A transpose and then multiply it, B transpose is going to be 1, 3, and -6, and A transpose is going to be -2, 4, and 5. Now if I kind of multiply B transpose into A transpose, this is what I'm going to get. 1 into -2, this is again -2. 1 into 4, which is going to be 4. 1 into 5, which is going to be 5. You can clearly see essentially this is actually becoming this only, right? This is becoming this only. You can verify it with the multiplication, right? So that means this is again verified. So I suppose you're understanding what I'm trying to say here. I'll just summarize what I did. Now in the summary, first thing I'd like to say that if A transpose is of Aij and is of order m into n, sorry, if A is of an order this, then the transpose is going to be A of Ji, and it's going to be of the order n into m. And another thing that is, the first property of the transpose is it's that the value of uh, A transpose is going to be the matrix itself. The second property was that if you multiply a scalar number into the into a matrix and then transpose it, that is going to be the scalar number into that transpose. The third property was the transpose of the sum is equal to the sum of individual transports, and the fourth property was A into B whole transpose is equal to B transpose into A transpose. So that is what we have discussed. So this would be about this video, guys. Thank you very much for watching this video. Just make sure that you explore perfect-scores.com. It's a very important website if you're looking to learn. And this would be a Facebook page to give us your valuable like, and this would be the email address where you can give me your valuable feedback. So this would be about this video, guys. Thank you very much for watching. I'll see you in the next